All right, gentlemen, I'm going to try to go over this test, this practice test. This is the one on confidence intervals. If you need to, you can obviously speed up the playback, 2x speed, whatever works for you. All right, we want to compute a 96% confidence interval for a population mean. Assume the population standard deviation, sigma, is known to be 10. The sample size is 50. What's the critical value going to be? Right? We know sigma, so we're looking for a z star. We can flip to the textbook, to the table, and we can look up 96% interval, or you can do an inverse normal test. If there's 96% of the data in the middle, that means there's 2% in either tail. So you're looking at either the second percentile or the 98th percentile. So if you're going to do it using the calculator, you would do inverse normal 0.98 for your middle. Right? I'm going to just flip to the table, and a 96% confidence interval. My z star is, now the table says 2.054, so that's the closest. Calculator would probably be a little bit more accurate and closer to 2.0537. Next, you've measured systolic blood pressure of a random sample of 25 employees. A 95% confidence interval for the mean blood pressure for the employees of this company is 122 to 138. Which of the following statements gives a valid interpretation of this interval? 95% of the sample employees have a systolic blood pressure between 122 and 138? No. 95% of the population? No. If the procedure were repeated many times, 95% of the resulting confidence intervals would contain the population mean systolic blood pressure. That's my interpretation of confidence level. So that looks okay, but they're asking me to which of the following statements gives valid interpretation of the interval, not of the level. So I like this. I like this answer, but it seems that it's more of an interpretation of the level. The probability that the population mean, well, we know confidence intervals are not probabilities, so that's a trap. I'm not going with that one. Right? If the procedure repeated many times, okay, 95% of the sample means would be between 122 and 138. No, that's not the interpretation of the level. It's 95% of the intervals generated would contain mu. So E is no good. So although I like C is a true statement. Because I have this none of the above, I think the answer is, my interpretation is, I am 95% confident that, I wish I had more space, that the mean blood pressure is between 122 and 138. Now maybe I'm just splitting hairs, and maybe the textbook might say C is okay, but the way we've been defining this is the interpretation of the level, not of the actual interval. So I like F. An analyst using a random random sample of 500 families obtained a 90% confidence interval for mean monthly family income for a large population. The interval is 600 to 800. If the analyst had used a 99% confidence level instead, he's going to have a wider interval. More confidence means you have to cast a wider net. So the interval would be wider and would have a smaller risk of being incorrect. Correct. Right? We're now 99% confident rather than 90% confident. In an opinion poll, 25% of a random sample of 200 people, it's a p hat, so that would be 50 over 200, 25%, said that they were strongly opposed to having a state lottery. The standard error of the sample proportion is approximately, so what's our standard deviation formula? It was p hat times 1 minus p hat over n, so that's 0.25 times 0.75 over 200 under the radical. I obviously need a calculator to do that. And I get 0.030619. Number 5, in preparing to use a T procedure, suppose we are not sure if the population was normal. In which of the following circumstances would we not be safe using a T procedure? So, outliers and strong skew. T procedures are, I'm starting at the bottom. T procedures are robust, so it's always safe? No, they are robust, but that doesn't mean it's always safe. Sample standard deviation is large. That makes no difference. Stem plot of the data has a large outlier. I can't go on if I have an outlier. Moderate skewness, that's okay. Roughly bell-shaped, that's great. That's perfect. So our answer is C. Number 6, some scientists believe that a new drug would benefit about half of all of the people with a certain blood disorder. So they think that P is 0.5. To estimate the proportion of patients who would benefit from taking the drug, the scientists will administer it to a random sample of patients who have the blood disorder. What sample size is needed so that the 95% confidence interval will have a width of 0.06? So our formula for margin of error is Z star times P hat 1 minus P hat over n, and we're going to try to solve for n. Now, because they said they think about half the people, I'm going to use 0.5. If they didn't give me a number, if they didn't say some kind of estimate or a belief in advance, I'd still use 0.5 because that's the most conservative. My Z star for a 95% confidence interval is 1.96, roughly 2 standard deviations. 0.5 times 1 minus 0.5 is 0.25 over n. I want this to have a width of 0.06. So I'm going to do a little algebra. And you don't need to see that. You could do that work yourself. But I get n equals 266.778. Uh-oh. So that wasn't one of my choices. Oh, I see what I did. The width of the entire interval is 0.06. So this should be 0.03 would be my margin of error. Okay, back to the drawing board with the calculation. And I get n equals 1067.11. I'm not going to round this, right? In order to make sure that I have a width that's no bigger than 0.06, I have to bump up. If I did 1067, I might get a width that's a little bit larger than 0.06. Right, number 7. In a poll, some people refused to answer questions. People without telephones could not be in the sample, and some people never answered the phone call in several calls. Which of these sources is included in the 2% margin of error announced for the poll? None. Margin of error has to do with sampling variability, not with bad sampling. I mean, you see your formula, it's p hat times 1 minus p hat over n, all under the radical. None of that has to do with under coverage or non-response. Number 8, researchers are studying a yield of crop in 2 locations. The researcher is going to compare 2 independent 90% confidence intervals for the mean yield in each location. The probability that at least one of the constructed intervals will cover the true mean yield at its location is none of these. Confidence intervals, we don't want to talk about probability, right? This 90% isn't the probability of capturing. It's a statement about the procedures. If we were to do these procedures many times, how many of those intervals would cover? So trap, none of these. Okay, so now we've got some free response questions. We've got 24 male rowers. We didn't choose a simple random sample, but we're willing to assume that these runners are a random sample. Great. So we need a 95% confidence interval for mu. So this is a one sample. I don't know sigma, so I think it's a one sample t interval with 95% confidence. The formula for that is x bar plus or minus t star with the appropriate degrees of freedom, n minus 1, times s, standard deviation of the sample, over root n. So you've got the data. You're going to have to plug those numbers into your calculator to generate this interval. But before we do that, we've got some conditions we need to check. One, the random condition. All right, we're told to treat it as a random sample. Two, 10% rule. It's safe to assume more than 10 times 24, which is 240 male runners. And then finally, large counts normality. I wish we had 30. We don't. So I'm going to have to graph this data. Now, when I make a box plot of the data, a little sloppy there, but I guess on that looks pretty darn symmetric. When I trace to find the 5-number summary, I see that this is 53.1. Q1 is 58.35. The median is 62.1. So median's about a little less than 4 above the first quartile. Q3 is 65.3, a little more than 4. And then my max is 69.3. No outliers. So the box plot shows no deviations from normality. Really, I'm just looking for severe skew or outliers because my sample size is pretty big. 24 is close to 30. So I'm good to go. I'm good to proceed. So I'm going to use the calculator to do my work for me. And I get an interval that goes from 59.76 to 63.82. I am 95% confident that, what am I estimating? That the mean weight of male runners in this town is between 59.76 and 63.82 kilograms. If these procedures were repeated many times, 95% of the intervals generated would contain mu. In context, of course.